Okay, so we learned how to estimate the demand for homogeneous product in the previous lecture. Today, we learn how to estimate the market power of firms. Now, what is the market power of firms? The market power of a firm is the firm's ability to price its above marginal cost. In other words, it is a firm's ability to make economic profit. The problem with measuring firms' market power is that firms' marginal costs are often unobserved to the researcher. And so we need a help of economic model to recover firms' marginal costs and their market power. We learn how to do this today. As empirical applications, we will be looking at Bettendorf and Verhoeven 1999, and Genesov and Moulin 1998 again, which we looked at in the previous lecture. So let's start with a simple case. Suppose that there are two firms competing in a quantity in a homogeneous product market, such that the two firms produce identical product and face exactly the same marginal cost of production. The inverse demand function is given by the linear form where A is the intercept parameter and B is the slope parameter. Note that the aggregate output cap Q is given by the sum of the outputs produced by the two firms. The total cost of producing output Qi is given by the constant returns to scale technology, where C is the marginal cost parameter. Assume that each firm chooses its own output level simultaneously. The firm I's profit is denoted by pi I, and the firm I maximizes its own profit by choosing its own output level. Here, P times Q is the total revenue, and C times Q is the total cost of producing output Qi. Firm I faces demand constraint, and so they cannot set the price freely. Substituting the inverse demand function into the price in the profit function, we have the profit in terms of output levels only. Note that the rival's output directly enters the profit of firm I through the aggregate output Q. And this is the source of the strategic interaction between the two firms. In particular, an increase in the output of the rival decreases the price and so reduces firm I's profit. The equilibrium of the game is given by the Nash equilibrium, where the output level of firm I is the best response to its rival's output, and the price satisfies a demand constraint. Now, how do we obtain the best response of a firm? We take the first order condition with respect to the output and set it equal to 0. You can see that the best response of firm I is decreasing in the rival's output. Now, note here that we have a best response function for firm 1 and 2, and so we have two equations with two unknowns, where the unknowns are the output produced by firm 1 and 2. Solving for Q1 and Q2 gives the equilibrium output level for firm 1 and firm 2, which is a function of the exogenous parameters of the model. We can see that the equilibrium output produced by the firm I is increasing in the demand intercept A and decreasing in the marginal cost C, which should be intuitive. Now, let me explain how the equilibrium is determined in this model graphically. This graph also demonstrates the uniqueness of the equilibrium at a very intuitive level. The picture here shows the best response function of each firm, and intersection of the two best response functions gives the equilibrium output level of the two farms. Now, let me heuristically argue that this is the unique equilibrium of the game. Suppose that the farm 1 produces 0 output. So here. What is the farm 2's best response output? The farm 2's best response output is given here. Okay, so this is how much farm 2 would produce, given that farm 1 produces 0 output. Now, given that the farm 2 produces this output, what is the best response of the farm 1? Farm 1's best response output is given by the level here. Okay, so this is how much farm 1 produces. Now, given that farm 1 produces this much, what is the best response output of farm 2? Farm 2 will best respond by producing this much. Okay, so this is going to be the farm 2's best response. Now, you can repeat this process, and you can see that this best response iteration takes you back to the Q1 star and Q2 star. You can start wherever you want, but the best response iteration always takes you back to the Q1 star and Q2 star, and therefore this is the unique equilibrium of the game. Okay, let's think about a more general case where n farms compete in the market where n can be an arbitrarily large integer. The inverse demand function is redefined so that the aggregate output is the sum of the outputs produced by the n farms. I want you to try and solve for the symmetric equilibrium of the game where every farm produces exactly the same quantity.